Please like, share and subscribe our channel to learn and enjoy our free online educational videos from class nursery to 10. Please click the bell icon to get all new updated videos. Lesson 1. Chemical reactions and equations. We have already learnt about physical and chemical changes of matter. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. You must have observed that magnesium ribbon burns with a dazzling white flame and changes into a white powder. This powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. A chemical reaction has taken place: change in state, change in color, evolution of a gas, change in temperature. Chemical equations: when a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. The simplest way to do this is to write it in the form of a word equation. Magnesium plus oxygen, reactants, gives magnesium oxide. Product. A word equation shows change of reactants to products through an arrow placed between them. The reactants are written on the left-hand side, LHS, with a plus sign, plus, between them. Similarly, products are written on the right-hand side, RHS, with a plus sign, plus, between them. The arrowhead points towards the products and shows the direction of the reaction. Writing a chemical equation. A chemical equation represents a chemical reaction. If you recall formulae of magnesium, oxygen and magnesium oxide, the above word equation can be written as Mg plus O2 gives MgO. Balanced chemical equations. The number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. Zinc plus sulfuric acid gives zinc sulfate plus hydrogen. This word equation may be represented by the chemical equation zinc plus H2SO4 gives zinc sulfate plus H2. Let us examine the number of atoms of different elements on both sides of the arrow. Element. Number of atoms in reactants, LHS. Number of atoms in products, RHS. Zinc 1 1, H 2 2, S 1 1, O 4 4. As the number of atoms of each element is the same on both sides of the arrow, equation is a balanced chemical equation. Steps to form balanced equation. To show how to balance the equation, the following equation is used. Fe plus H2O equals Fe3O4 plus H2. Step 1. First of all, draw the boxes around each formula as shown below. Fe plus H2O equals Fe3O4 plus H2. Step 2. Find out the number of atoms of each element. For example, on reactant side, 1 for Fe, 2 H, and 1 O. And on product side we have 3 for Fe, 4 for O and 2 for H. Step 3. Start to balance the equation with the compound having maximum number of atoms. While balancing does not alter the formula of the compound. Step 4. One by one balance each element on reactant and product side. Fe plus 4H2O equals Fe3O4 plus 4H2. Step 5. After balancing number of atoms on both the side of the equation, finally check the correctness of the balanced equation. 3Fe plus 4H2O equals Fe3O4 plus 4H2. Step 6. Then write the symbols of the physical state of reactants and products as shown below. 3Fe plus 4H2O equals Fe3O4 plus 4H2. This equation represents the balanced equation. Types of chemical reactions. Chemical reactions involve the breaking and making of bonds between atoms to produce new substances. Combination reaction. Calcium oxide reacts vigorously with water to produce slaked lime, calcium hydroxide, releasing a large amount of heat. CaO, quick lime, plus H2O equals CaOH2, slaked lime. In this reaction, calcium oxide and water combine to form a single product, calcium hydroxide. Such a reaction in which a single product is formed from two or more reactants is known as a combination reaction. Decomposition reaction. 2FeSO4. Ferrous sulfate, heat equals Fe2O3. Ferric oxide plus SO2 plus SO3. In this reaction you can observe that a single reactant breaks down to give simpler products. This is a decomposition reaction. Displacement reaction, FeS plus CuSO4. Copper sulfate equals FeSO4. Iron sulfate plus Cu. In this reaction, iron has displaced or removed another element, copper, from copper sulfate solution. This reaction is known as displacement reaction. Double displacement reaction, Na2SO4. Sodium sulfate plus BaCl2. Barium chloride equals BaSO4. Barium sulfate plus 2NaCl. Sodium chloride. Such reactions in which there is an exchange of ions between the reactants are called double displacement reactions. Oxidation and reduction. If hydrogen gas is passed over this heated material, CuO, the black coating on the surface turns brown as the reverse reaction takes place and copper is obtained, CuO plus H2. Heat, Cu plus H2O. If a substance gains oxygen during a reaction, it is said to be oxidized. If a substance loses oxygen during a reaction, it is said to be reduced. Have you observed the effects of oxidation reactions in everyday life? Corrosion. This process is commonly known as rusting of iron. The black coating on silver and the green coating on copper are other examples of corrosion. Corrosion causes damage to car bodies, bridges, iron railings, ships and to all objects made of metals, especially those of iron. Corrosion of iron is a serious problem. Rancidity. When fats and oils are oxidized, they become rancid and their smell and taste change. Usually substances which prevent oxidation, antioxidants, are added to foods containing fats and oil. Keeping food in airtight containers helps to slow down oxidation.